Our fingerprints are unique. No two are alike, not even on identical twins. This makes them incredibly valuable. For centuries, these tiny ridges on our fingertips have held the key to solving mysteries. From petty theft to high-profile murders, fingerprints have cracked countless cases. They are silent witnesses, leaving invisible traces of our presence at crime scenes. Think of your fingerprint as a coded message from your body. It whispers a tale only visible under a detective's careful eye. Long before DNA analysis, we relied solely on these intricate patterns to link criminals to their crimes. Today, even with all the advancements in forensic science, fingerprints remain a cornerstone of criminal investigations, a testament to their enduring power. They are the ultimate proof of presence. They can't be altered, disguised, or erased. And while other evidence may be circumstantial, a fingerprint puts you at the scene of the crime. It's hard evidence, undeniable and irrefutable, linking you to the act itself. The use of fingerprints for identification dates back centuries. Ancient civilizations, including the Babylonians and Chinese, utilized fingerprints as a form of signature. They recognized the uniqueness of these patterns. In ancient China, fingerprints were pressed into clay seals, serving as a rudimentary form of identification on important documents. Fast forward to the 19th century, when scientific interest in fingerprinting truly blossomed. Sir William Herschel, a British official in India, began collecting fingerprints. He used them to prevent fraud and ensure identity in contracts. His work, along with the groundbreaking research of Francis Galton, a cousin of Charles Darwin, established the scientific basis for fingerprint identification. Galton's meticulous studies of fingerprints, published in his book Fingerprints, revolutionized the field. He categorized fingerprints into three main patterns: loops, whorls, and arches. These classifications, still used today, provided a systematic way to analyze and compare fingerprints. Galton's work laid the foundation for modern fingerprint identification systems. The advent of DNA technology in the late 20th century marked a paradigm shift in forensic science. Suddenly, investigators had a powerful new tool at their disposal, one that could unlock secrets hidden within our very cells. DNA fingerprinting, also known as DNA profiling, offered a level of accuracy and specificity previously unimaginable. Unlike traditional fingerprinting, which relied on the visual comparison of ridge patterns, DNA profiling delves into the very building blocks of our being. By analyzing specific regions of our DNA, scientists can create a unique genetic fingerprint, akin to a biological barcode identifying each individual. The impact of DNA technology on criminal justice was profound. It not only revolutionized the way crimes were investigated, but also provided a means to revisit past cases, exonerating the wrongly convicted and shedding light on cold cases that had long gone unsolved. DNA evidence became the gold standard in forensic science, its power to link suspects to crime scenes and victims unparalleled. Section 4. Cracking the code inside DNA fingerprinting. DNA fingerprinting may seem like science fiction, but the process, while complex, can be broken down into key steps. It all starts with a biological sample, be it blood, saliva, hair, or even a touch. This sample holds the key to unlocking an individual's unique genetic code. The first step is DNA extraction, carefully isolating the DNA molecules from the collected sample. Next comes the polymerase chain reaction, or PCR, a groundbreaking technique that amplifies specific regions of the DNA, creating millions of copies for analysis. These amplified DNA segments are then separated and analyzed based on their size and sequence, revealing distinct patterns unique to each individual. Short tandem repeat, or STR analysis, is a common method used in DNA profiling. STRs are short repetitive sequences of DNA that vary in length between individuals. By examining multiple STR markers, scientists can generate a DNA profile with a high degree of accuracy. Section 5. Pioneers and their prints: Galton, Jeffries, and the future. The field of forensic science owes a debt of gratitude to pioneers like Francis Galton and Alec Jeffries. Galton's meticulous studies laid the foundation for fingerprint identification, establishing its scientific basis. His work transformed fingerprinting from a curiosity to a powerful tool for criminal justice. Jeffries, on the other hand, ushered in the era of DNA fingerprinting. His discovery of the variability of DNA sequences revolutionized forensic science, providing an unprecedented level of accuracy in identifying individuals. His work not only transformed criminal investigations, but also had a profound impact on paternity testing and other fields. These pioneers, each in their own way, transformed the way we approach criminal justice. Their contributions continue to shape the field of forensic science, inspiring new generations of scientists and investigators to push the boundaries of what's possible. Section 6. Beyond the print forensic science in the 21st century. Forensic science, however, is not solely reliant on fingerprints or DNA. It's a multifaceted field, constantly evolving and incorporating cutting-edge technologies. From trace evidence analysis to ballistics and digital forensics, investigators have an arsenal of tools at their disposal to solve crimes. Take, for instance, the analysis of trace evidence. Microscopic fibers, paint chips, or even soil particles can provide crucial links in a criminal investigation. Ballistics experts can examine bullet fragments and shell casings to determine the type of firearm used and potentially link it back to a suspect. And in our increasingly digital age, digital forensics plays a crucial role in solving crimes. Investigators can recover deleted files, track online activity, and analyze data from smartphones and computers to uncover crucial evidence. The field of forensic science is constantly evolving, embracing new technologies to stay one step ahead of criminals. Section 7. The future of fingerprints, unsolved crimes and evolving technology. So what does the future hold for forensic science? As technology continues to advance, we can expect to see even more sophisticated tools and techniques emerge. Artificial intelligence, for example, is already being used to analyze crime scene data and identify patterns. Nanotechnology holds promise for developing even more sensitive and accurate methods for detecting and analyzing trace evidence. And with the increasing availability of genetic databases, DNA profiling is likely to become even more powerful in solving crimes, potentially even predicting an individual's predisposition to criminal behavior, though the ethical implications of such advancements are sure to be debated. Despite these advancements, one thing remains certain: fingerprints will continue to play a vital role in criminal investigations. Their uniqueness, permanence, and ease of collection make them an invaluable tool for linking individuals to crime scenes. The future of forensic science is bright, with fingerprints remaining a cornerstone of this ever-evolving field.